Okay, hello everyone. Today we'll be talking about the Math Kangaroo 2018. And let's begin. So, which of the following has the highest value? And we just need to calculate each expression individually. And those are the answer for each expression. And we pick the largest one. And question 2. So, I will enter each door exactly once. And which room am I going to end up with? So, you begin with here and you just go and you have a cycle here. You're gonna loop back into this one. So room number 2. Question 3, we got 7 stones and a hammer. Whenever I hammer the stone, we're gonna break into exactly 5 smaller stones, which means it's going to create 4 more stones each time. So the remainder of 4 should be 3, that number, which is D. And question 4, we have 12 cubes glued together. And we want to know the number of cubes that has exactly 4 surfaces that will be painted. Which means 2 of the faces of that cube will be intersecting with other cubes. And we count there's a total of 8 cubes. So we pick C. Question 5. So we have 2 different statements, and this is the only one that we care. Green aliens that lives only on Mars. So logically we can conclude that there's no aliens on other planets. So no green aliens on Venus. Question 6. So we need to find the measurement of the larger angle of the rhombus. So here is a formula that we need to know. So for a polygon, the sum of the total inner angle is going to be the size minus by 2. And multiply 180 if that one is a regular polygon, and we're gonna divide the number of sides, and this gives us the angle of each angle of the polygon. And there's a rhombus exactly has an angle that directly equals to the inner angle of the polygon. So according to our calculation, we pick 135. Question 7. There's 65 balls in a box. 8 of them are white, the rest of the balls are black. And in one move, these are most 5 balls that can be taken out from the box. And we are not picking out of the balls, putting back the balls. So what is the smallest number of moves we must make to guarantee that we are getting at least 1 white ball? So the total number of the ball that we need to remove is the total number of the black plus 1 extra white ball, and we're gonna seal that number divided by 5, which is 12, which we pick B. Question 8. So we get a rectangular prism with the surface area ABC, and we need to find the volume. So again, this is a very classic one. So when we multiply all those surface area together, we're gonna get the square root of the volume of the rectangular prism, and this is the expression. Question 9. So how many ways can number 1001 be written as the sum of 2 primes? So notice this is an odd number. So 2 primes, it must be an even prime plus an odd prime. And the only even prime is the number 2. And 1001 divided by minus 2 equals to 999, which is not a prime, so this is impossible. Question 10. So we get A over B equals to B point A. This is a decimal, and we need to figure out A and B. This question is very interesting. And first, we're gonna multiply both sides by b and rewritten the decimal expression like this. And what we get is this. Since a is a digit, a is between 0 and 9, and this is greater than b squared, which means that b is between 1 and 3. And for each value of b, we sub in back into our original equations, and we can solve for a, and we just try those three values of b, and when b equals to 2, we get a solution of this, and we've managed to solve a and b. Question 11. So two cubes of v and w, they are intersecting with each other. So basically, this cube is like dig inside the body of this cube, okay? That's how the diagram is. So the intersection is 0.1 of the first one, and the intersection is the 0.15 of the second one. And we just need to change them to integers, and we get an expression between those two volumes. And question 12, we are given a graph and we need to guess the shape of the container. Based on the graph, the slope is very high and it becomes very small. So, and we are given that we are infusing the water at a constant rate. Therefore, it must rise very fast at the beginning and become very slow near the end. And the slope is always becoming slower and slower. So D is our best choice because it's easy to feel like the bottom because it has a less surface area. And question 13, so there's 5 cars and 3 of them is given to Nadia and the other 2 is given to Rainy. And Nadia got 3 cars and multiply them together, and Rainy do the same thing, and when they add the 2 products together, they got a prime. So what it tells us is that the greatest common divisor of those 2 products is going to be 1. Otherwise, it's not going to be a prime. And how do we make sure that their common divisor is equal to 1 is that if 2 numbers inside those 5 cars, if they share some kind of factor, we're gonna put it inside the same group. Otherwise, the product is going to be split and it's going to have some kind of greatest divisor other than 1. So 4 and 6, they share a factor of 2. We put them together. 6 and 3, they has a factor of 3. So we also need to put them together. So those 3 goes together, the other 2 goes to Rainy, and we add them together and confirm that this is indeed a prime. Well, the opposite is not always true, so if we are given that 2 products, they are equals to, if they have a greatest common divisor of 1, we cannot say that the sum of them is equal to a prime. The opposite is not true. And yeah, we just summed the 3 cards that's given Nadia and we solved the problem. Yay! So question 14 is very easy. The first one is a negative number. You just reverse it and you just calculate it and you get the answer. Question 15, so an arc. We are given an arc of a certain portion of a circle and we are given the area. So we first calculate the radius. So the radius can be obtained by the area divided by pi and take the square root. And then we're gonna calculate the circumference of the circle, which is the radius times 2 times pi, and we take the 1/6. Question 16. Whoa. So we are given a triangle, and what we need to determine is the sum of those 6 variables. And we're given the midpoint of this triangle here. So the midpoint formula is the first value plus the second value and divided by 2. And that's all of the equation relationship we are given, and we just add them all together and we get a sum of all the variable. And question 17, so this is another logic problem. So what we need to do is find a situation where exactly three of the prediction come true. So notice that if 5 is true, then condition 1 is also true. If condition 3 is true, then condition 4 is true. And condition 2 is kinda alone. And condition D satisfies 5, which means 1 is also true, and it also satisfies 2, which is 3 conditions are true. It's violating number 4. Therefore, it has exactly 3 conditions to be true. And question 18, this is actually a GCD and LCM problem. So each time we are rotating a pentagon of 21 degrees from the center, and we need to find that when does this fit back to the shape again. And it must be a common divisor of both 72 and 21 in order for that to fit. And how do we find the least common multiple? Is we first find the greatest common divisor, and we're gonna multiply those two together and divide it by the greatest common divisor, and it's going to be rotating 7 times of this point to the other point, which means it's rotating twice if you take the remainder of 5, which corresponding to this shape. Question 19, so we are given a number, and which of the number does not divide this? So this one, we first take the 18 out of the second one, which is larger, and we combine, we get 19 times this number, and it does not have a factor of 7, which means it cannot divide this one. We pick C. In question 20, we get a shape, and what we know is that there's a lot of right angle, and we begin with those two, right? And since this is in a line, so a straight line has an angle of 180, and you subtract the right angle, and you got those two should add up to 90 degrees. The same with those two, and this is a triangle, and the inner sum angle of the triangle is 180, and you subtract those two, you obtain those two. Since those are two lines, those two angles should be the same, and this is a quadrilateral, and this thing here, those two should add up to 180, and those two angles are the same, and that's how we obtain our result. And question 21. And question 21, so we get a very special shape here, a triangle prism. And what we know is that any 4 squares, they should have the same sum, and we can easily prove that each of the columns, they have the same sum, since each of the number is exactly from 1 to 6. So this column has a minimum, this one has a maximum, and they must be equal to each other. So this one, the minimum is 7, this one maximum is 7. In order to make them equal to each other, they must be equal to 7. So we can solve x equals to 2 because this thing adds up to 7. And question 22. So we get an equation, okay, and we need to find the value of n squared plus m. So use the root formula, we square one of them and add the other one, and we get this. Notice that it doesn't matter that which the root you set equals to n and which one you set to m. It's always going to be the same result based on my testing, so you can so you don't need to care about that. And question 23. This is another logic problem. One of them is lying. So if A is lying, the problem is there's 2 shortest person or 2 tallest person. If B is lying, there's 2 shortest person. If D is lying, nobody is the shortest, which is wrong. They have the distinct heights. So C must be the one that's lying. And based on the logic, so D is the smallest. It cannot be the tallest. And C is lying, so it cannot be tallest. And A is saying the truth. He is not the tallest. So B has to be the tallest. And that's how we use the logic to figure this puzzle out. And question 24. So this one is nothing to talking about. We are given a relationship of a function relationship, and we are given a value, and we need to find a value of f0 to f3. And you can just like this. If you want to find 2, you just make x, y equals to 1. And if you want to find 3, set one of them equals to 1, one of them equals to 2. And if you want to find a 0, you're going to work it backwards and set one of them equals to 0, set the other one to 1. And those are the value of 3 different functions, and you're going to add them together and you get a result. And question 25, so we are given a quadratic equation, and there's a circle that intersecting both two x-intercept and the y-intercept. And based on that, we know that the shape should be symmetrical since the circle intercepts those 2 points, and it must be on the perpendicular bisector line, and that line also passing through the vertex of this quadratic relationship. And yeah, this thing should be symmetrical. So this point, what we are looking for, should have the same y coordinate as the y-intercept. And using by finding the vertex, which we know that the x value equals to -1/2 p, and we are further extending it. We multiply that by 2, which is -p, and that's how we figure out the coordinate of the fourth point. And question 26. So we got a billiard, and we need to find the distance of this after bouncing 3 times. So we know that the angle of inflection equals to the angle of reflection. Those 2 angles are equal, and we can use the similar property, and we know the size of the billiard table, and we get this. We can figure out this and use the similar, figure out this. Again, using the table length, figure out this and use the similar, and use the length and use the similar, and we obtain this is 1.8. And question 27. How many real solutions does this thing have? So we just need to draw out the graph. Begin with this, and the absolute value you reflect it, and you bring this down and you reflect it again, and you just need to count how many of them are lies on the y equals to 1, this line. And yeah, this is how does the graph looks like. You just need to draw a rough sketch of it. I think you can also do this algebraically, but I think graph makes more visual sense to me, so that's how I figure out this problem. And question 29. We are given a regular hexagon, and what we need to do is finding the ratio of those two. And we're gonna use this triangle GIH as a medium to determine the ratio between that and the shaded triangles. So since the height of those 2 triangles, GIH and GED, they should be twice, and the base should also be twice. So the area ratio should be square of the twice, which is 4. And we subtract the smaller one from the big one. We obtain the area of this trapezoid, which is, and the ratio of this and this is 1/3. And in order to figure out the ratio of FGI and GIH, what we're gonna do is find their base since they have a common height on FC. And if we draw a parallel line against it, D and M, right? We just DM is parallel to FE, and this is going to split FC into two equal parts. And since the shape is already symmetrical, so MI and MH, they should be the same. And the total, suppose the total is 1, right? And this is a half. And we already know this is, okay, never mind. So let's say ED is 2x, right? And this is a parallelogram. FM equals to ED equals to 2x. And we already discussed the ratio of IH and ED like previously. And we can express IM to be 1/4 of 2x, and we get that Fi equals to 3 over 2x, and we can use the ratio of Fi and IH, determine the ratio of those two triangles, and we multiply two ratios together, and we obtain the ratio of two shapes that we are looking for. And question 29. So suppose there's there's a class and there's 40% more girls than boys. And so suppose there's X boys and there's 1.4x girls. And the probability of picking one girl and one boy is going to be this. This is the first pick if you get a girl, and second pick you get a boy. This is the probability that you first pick get a boy, and second pick you get a girl, and you add those two probabilities together, you get a total probability equals to 1/2, and you just solve this equation. You should be getting the value of the value of x, and you have 2.4 times x, you get a value of the class size. In question 30, you can just use a calculator if you want. But if we are doing this without a calculator, this is how we're gonna do it. So first, we're gonna eradicate all of the power of 10. And we're gonna find the remainder when divided by 10. And this is congruent to 8. So the bottom one, the rightmost one is equal to 8. And once we determine that, finding the remainder of the 11 when we have the alternating digit here, and this whole number should be congruent to the alternating mode 11 of the digit, and we can see that this one is congruent to 3, and x must be equals to 3 because it's between 0 and 9. And that's how we figure out the two digits. And thank you for watching this video, and see you in the next one.